Welcome back to the Deep Dive. We're digging into a topic today that I think on the surface it sounds a little technical, but it is actually this massive strategic power play.
Oh, absolutely. It is completely reshaping how the internet works.
Right, and how AI thinks, and frankly, just how some of the biggest companies on Earth are spending their money. We're calling it Silicon a la carte.
I mean, it's a perfect title. We are witnessing this this really fundamental shift in the architecture of the digital world. It's a massive move away from the sort of general purpose era into something much more bespoke.
And to set the stage for that, I want to borrow an analogy from our research that I think it nails the vibe perfectly. So imagine you are absolutely obsessed with sandwiches.
Okay, I'm with you.
And for years, you've been going to the store buying that standard white loaf of bread, you know, the one in the plastic bag that literally everyone buys.
Right, the generic stuff.
Exactly. And it holds the turkey and cheese together just fine.
Yeah.
But one day you decide that fine just isn't enough anymore. You want the perfect sandwich.
The ultimate sandwich.
The ultimate. So you stop going to the store entirely. You build a bakery in your house. You source your own grain. You tweak the yeast. You adjust the crust density, all so it fits your specific sandwich perfectly.
Which, I mean, it's a lot of work for a sandwich.
It is a ridiculous amount of work.
Yeah.
But that is exactly what big tech is doing right now, except instead of sourdough, they are baking silicon chips.
That really sets the scene for what industry insiders are calling this massive tech party shift.
Right.
Because for decades, everyone was basically eating from the same buffet. You had Intel serving up CPUs for servers, maybe Qualcomm bringing the chips for your mobile phones.
It's a very standardized menu.
Totally standardized.
Yeah.
But now, the party has completely changed. Google has shown up with this gourmet silicon dish they cook themselves specifically for AI.
And Amazon is walking in with a massive banquet optimized just for the cloud.
Right, and then Samsung is presenting this homemade recipe designed strictly for their Galaxy devices.
So it's not a potluck anymore. It is a cutthroat cook-off.
Oh.
And our mission for this deep dive is to figure out why. Because I kind of have to play devil's advocate right out of the gate here.
Please do.
We are talking about companies whose core businesses are, search engines and e-commerce and selling phones. Suddenly they think they can out-design Intel.
It sounds crazy.
Intel's been doing this for 50 years. Isn't this just a massive case of corporate hubris?
It really looks like hubris on the surface.
Yeah.
But if you look at the data, specifically the reports we have from CSET, which is the Center for Security and Emerging Technology, it's not that Intel is bad at making chips.
Okay.
It's that Intel is trying to make a chip that works for everyone.
So it's a jack of all trades, master of none situation.
Exactly. And we are living in what engineers call a post-Moore's Law world.
Right, because for a long time you could just wait, 18 months?
Roughly 18 months, yeah. And the generic chips would just naturally get twice as fast and much cheaper. But that train has slowed down significantly.
It's hitting physical limits.
Yes. And meanwhile, the demand for computing power specifically for AI and these massive cloud operations has just skyrocketed.
So the generic stuff simply can't keep up with the appetite.
It can't keep up efficiently. That's the key word. If you are Amazon, you really don't care if a processor runs a video game or a spreadsheet well.
You don't care at all.
You only care if it runs the AWS cloud efficiently. So when they buy a generic chip, they are essentially paying a generality tax.
Oh, that's an interesting way to phrase it.
Yeah, they're paying for silicon real estate and features on that chip that they will literally never use.
And when you're operating at the scale of a megacorporation, that tax really adds up.
It adds up to billions. Designing a custom chip is incredibly hard. It is like assembling a puzzle with a billion pieces, but the prize is juicy.
Very juicy from what I read.
Oh, yeah. The CSET studies found that specialized custom chips can reduce costs by a factor of 10 to 1,000 times for specific AI tasks compared to general chips.
Pause there. 1,000 times. That's
Yeah.
not a typo in the research.
That is not a typo. That is the upper N for highly, highly specific tasks, yes. Think about it like a suit.
Okay.
You can buy a suit off the rack. It might fit okay. Maybe the sleeves are a little long. Maybe the shoulders are tight. That is your general purpose chip.
Right. It works, but it's not perfect.
But a custom chip is a bespoke, tailored suit. It moves exactly how you move. If you are running millions of servers fitting okay, actually costs you a fortune in wasted electricity and cooling.
Okay, that makes total sense. If you're big enough, off the rack is actually more expensive in the long run. So let's look at who's actually doing this. We have to start with Google or Alphabet, because they seem to be the ones really pushing the envelope on the pure science side.
Google is absolutely a pioneer here. They introduced the TPU, or Tensor Processing Unit, way back in 2016.
And the name kind of gives it away, right? Tensor ties directly to TensorFlow.
Precisely. TensorFlow is their open-source software library for machine learning. And the TPU was designed from the ground up specifically to run that software.
So the hardware was built for the software.
Yes. And this is where we have to get just a little bit technical to understand the breakthrough. The sources talk extensively about avoiding the von Neumann bottleneck.
Right, and I've seen that term thrown around in computer science textbooks.
Yeah.
But for us non-engineers, what is the bottleneck exactly? I know it's kind of like a kitchen, right?
It is very much like a kitchen. You have the chef, that's the processor doing the work.
Chopping the vegetables, doing the math.
Exactly. And you have the fridge, that is the memory, where all your ingredients or your data are stored. In the traditional von Neumann architecture, the fridge is on the complete opposite side of the room.
So every single time the chef needs a carrot, they have to walk all the way across the kitchen.
Every single time. They walk over, they get the data, they walk back, they do the math, and then they walk back to put the answer in the fridge.
That sounds exhausting.
It is. And in AI training, you are doing this billions of times a second. You end up spending more energy and more time just moving the data than actually computing it. It's a massive traffic jam.
And Google looked at that architecture and basically said, this is stupid.
Essentially, yes. The TPU physically puts the memory and the compute right next to each other. It is like moving the fridge right next to the cutting board. You aren't walking anymore. You are just cooking.
And that physical layout change, that's where they get that massive performance per watt jump that everyone talks about.
Right. Performance per watt is the golden metric in this industry. When you are paying the electric bill for a data center, the size of a football field efficiency isn't just about being green.
No, it's about profit margin.
Exactly. And by 2025, Google had invested billions into clusters of these internal chips. It allows them to confidently say, no more NVIDIA for everything. We are cooking our own GPU for AI.
It's incredible to think that they redesigned the physical hardware just to make their software run better.
Yeah.
It's total integration.
It really is.
Now, moving from search to the store, let's talk about Amazon, specifically AWS. They seem to have taken a slightly different approach than Google.
They have. Amazon's strategy is a bit less about scientific breakthrough and much more about pure logistical dominance. They have a full lineup now.
The buffet of custom chips.
Right. You have Graviton, which is their general server chip. You have Trainium for training AI. And you have Inferentia.
I love the names. They're very literal. Inferentia is obviously for inference.
Yes, it is. And it's important to distinguish that. Training is teaching the AI model that takes months and massive amounts of power.
Great, reading all the books.
Exactly. But inference is when you actually ask Alexa a question and she answers you. That has to happen in milliseconds. Amazon realized they needed highly specialized tools for both of those very different jobs.
This didn't just happen overnight for them, though. They didn't wake up one Tuesday and decide to build chips.
No, the pivotal moment was back in 2015 when they acquired a company called Annapurna Labs. It was a relatively small Israeli startup. At the time, people were really confused. Why is an online bookstore buying a chip designer?
But looking back, that was the seed for this entire AWS hardware empire.
It was. Since that acquisition, Amazon grew its design team by 10 times. And it brings us right back to that my kitchen, my rules philosophy. For Amazon, the motivation boils down to the two C's, control and cost.
And we have studies from IBM in our stack confirming that custom chips lower total costs by optimizing the hardware and software together. But I want to ask about the conflict of interest here.
Okay.
Because Amazon uses these chips for AWS, right? So if I am a company renting server space from Amazon...
You are likely running on those Graviton chips. And because Amazon designs them entirely in-house, they don't pay a margin to Intel.
Right.
Which means they can offer you a lower price for cloud hosting while actually keeping higher margins for themselves.
That is a brutal competitive advantage.
It is brutal. Plus, for a cloud provider reducing latency, the actual delay in processing is crucial.
Yeah.
If you're running a heavy AI service like Anthropic on AWS, shaving off milliseconds really matters.
Yeah, it's the difference between a clunky app and magic.
Exactly. If Amazon can save megawatts of power in milliseconds of time, they simply win the cloud war.
So Google is solving for AI bottlenecks. Amazon is solving for cloud economics. Now we have to talk about Samsung.
Oh, Samsung.
Yeah, and this is where my brain starts to hurt a little bit because their position in all of this feels very complicated.
Complicated is definitely putting it mildly. Samsung is a unique beast in this landscape. See, Google and Amazon are what we call fabless.
Meaning they don't have fabrication plans.
Right. They design the chips, they draw up the highly complex blueprints, but they send them off to a foundry, usually TSMC in Taiwan, to actually get printed. They don't own the factory.
Right. They're just the architects, not the construction crew.
Exactly. Samsung, on the other hand, is both. They are an IDM, an integrated device manufacturer. They bake the bread and they own the bakery.
And their main custom product is the Exynos chip, right? The one used in the Galaxy phones.
Yes. And the motivation there is pure differentiation. The mobile market is an absolute knife fight.
It really is.
By using custom silicon, they can optimize battery life much better than if they used a generic Qualcomm chip. They can build in specific security features that are hard-coded right into the physical device. It gives them complete control over the entire ecosystem of the phone, basically trying to match what Apple does with their chips.
But here's the part I find completely fascinating. They are designing chips to beat their competitors, but aren't they also manufacturing chips for their competitors?
That is the massive tension in their business model. They act as a foundry for other companies. There have literally been times where Samsung's foundry division was manufacturing chips for Apple, while Samsung's mobile division was actively suing Apple.
That is wild. That is like a restaurant that cooks its own signature dish to win a Michelin star, but also lets the restaurant across the street use their kitchen to prep their food.
It is an incredibly delicate dance. They need to prove their custom Exynos chips are the best for their own phones, but they also need to prove their manufacturing lines are totally neutral ground for their other clients.
Which is a tough tightrope to walk.
Very tough. Because if they fail at the custom chip, which they actually have, there have been overheating issues with Exynos in the past. It hurts their brand twice. It obviously hurts the phone sales, but it also makes their foundry clients question their manufacturing process.
High risk indeed. Okay, so we've looked at the big three, Google, Amazon, Samsung. I want to zoom out a bit. We talked about cost and performance. But is there something else driving this massive shift, something maybe geopolitical?
Absolutely. You really can't talk about chips today without talking about supply chain security.
Oh, right. The trauma of 2021 and 2022. I remember trying to buy a car and being told there was a 6-month wait because they were missing a 50-cent semiconductor.
That era was a massive wake-up call for literally every CEO on the planet. The reliance on a very fragile, highly centralized global supply chain for generic parts was exposed as a fatal weakness.
A single point of failure.
Precisely. By designing their own chips, these companies gain quite a bit more control over their own destiny. They aren't as completely reliant on the specific release cycles of an Intel or a Qualcomm.
It's about resilience. If you control the design, you can pivot faster if the supply dries up.
Exactly. And there's a really big but here. We need to sprinkle some salt on this custom silicon recipe because this is not a magic bullet.
I was going to ask about that because if it's so incredibly great and saves so much money, why isn't everyone doing it? Why doesn't Spotify bake its own chips?
Because the barriers to entry are just astronomical. First is the cost. You need billions in initial R&D just to get to the starting line.
So no bootstrapping this in a garage.
Not at all. This is not a game for scrappy startups. You need incredibly deep pockets to even play.
And it's not just money, it's talent.
Yeah.
I imagine there aren't that many people in the world who actually know how to design a TPU from scratch.
There is a massive scarcity of expert chip designers globally. It is an extremely specialized skill set, and there has been a severe post-pandemic shortage of this specific talent. Everyone, Google, Amazon, Meta, they are all fighting tooth and nail for the exact same small pool of engineers who understand chip architecture at this microscopic level.
And if you manage to hire them and you spend the billions and then the chip just doesn't work,
then you have wasted years of runway. And we have seen technical failures. If you bake a bad loaf of bread, you throw it out and you lose $5. If you design a bad chip, you lose an entire generation of product innovation.
Ouch.
It is ultra high risk, high reward. To go back to your restaurant analogy, it is exactly like opening a very high-end restaurant. You could become the best in town and make a fortune, or you could go bankrupt very, very quickly.
So it's essentially a high-stakes poker game played with silicon wafers.
It really is. And fundamentally, it's all about tech sovereignty. These mega corporations want to own their future. They want the optimization, the massive savings, and the competitive edge that generic chips simply cannot provide anymore.
It really feels like we are watching the entire industry mature in real time. It's moving from just buying whatever works to building exactly what we need to survive.
And this trend is only accelerating AI development. The ability to train these massive new language models depends entirely on this specialized hardware. And frankly, it puts immense pressure on traditional chip makers like Intel,
Right.
because they are standing there watching their absolute biggest customers suddenly become their biggest competitors.
That is a brutally tough spot to be in. So before we wrap up, I want to look forward. What does this mean for the listener? Does this actually change your life, or is this just back-end baseball that only engineers care about?
It changes everything because it fundamentally changes the speed of innovation. As AI becomes integrated into absolutely everything we do, the hardware running chip becomes the ultimate differentiator. The company with the best custom chip might just have the smartest AI.
Because they can iterate faster.
Exactly. If Google's chip is 100 times more efficient than the baseline, their AI can be smarter, faster, and cheaper than any competitor who is still relying on generic parts.
Which leads me to a final provocative thought for everyone to mull over. We've been talking all day about these absolute giants, Google, Amazon, Samsung. They have the billions to spend on this. But does this trend mean that true hardware innovation is now only accessible to the giants? Are we creating a moat so wide that no startup can ever cross it?
That really is the billion-dollar question, isn't it? Will this consolidate power entirely at the top, or will this somehow inspire a new wave of rebel chips and new open architectures that we haven't even thought of yet?
It is something to think about the next time you ask your smart speaker a question, and it answers instantly. That answer started in a custom-baked kitchen. That is it for this deep dive into the world of custom silicon. Thanks for listening, and we'll catch you on the next one.